Welcome to another u-Substitution definite integral example. In this example, we are trying to evaluate the definite integral from 6 to 8 of 1 over x squared minus 12x plus 40 dx. So in this case here, again, this lends itself, when we have 1 over a quadratic, that lends itself to a tan inverse. So 1 over a quadratic means we should try a tan inverse format. Which means we need to complete the square. So we are looking at a definite integral from 6 to 8 of 1 over that x minus 12x will go to, we would keep x squared minus 12x. Negative 12 divided by 2 is negative 6, and squared would require a plus 36. Then we had our original plus 40, and we should subtract off that 36 so that we wind up with 40 as our constant term, dx. So this becomes the definite integral from 6 to 8 of 1 over x squared minus 12x plus 36 is x minus 6 squared. 40 minus 36 is 4, or 2 squared, however you want to view it. At this point, let's go ahead and make our u be x minus 6. Then we have du is simply dx. Converting our bounds, we have our lower bound of x equals 6, would correspond to u equals 6 minus 6, or 0. Our lower bound, or sorry, our upper bound we are looking at x equals 8, which would correspond to u equals 8 minus 6, or 2. So we can go ahead and plug into our definite integral. Our bounds now become 0 for the lower bound, 2 for the upper bound. Then we have 1 over u squared plus 4 is 2 squared du. This is our special tan inverse case with a equals 1. Sorry, with a equals 2. So we know an antiderivative for that. We have 1 over a, so 1 over 2. Tan inverse of u over 2. And then we're evaluating from 0 to 2. So this becomes 1/2 tan inverse of 2 over 2 minus 1/2 tan inverse of 0. We're looking at 1/2 tan inverse of 1 minus 1/2 tan inverse of 0. Remember, tangent is sine over cosine. So tan inverse of 1 This is where sine and cosine equal each other. Tan inverse of 0 happens where sine equals 0. And so we wind up getting 1/2 times pi over 4 minus 1/2 times 0, otherwise known as pi over 8. So again, this is how we can go about finding the definite integral when u-substitution is involved. I here used method 2, where I converted the bounds into u. And that is the end of our section on u-substitution. In the next videos, we will take a look at a new technique called integration by parts.